Okay, so let's go ahead and take a look at this lesson. So this lesson has the perpendicular bisector theorem. If these two lines are perpendicular and MA is equal to MB, then I can draw diagonals, and those diagonals would be congruent. And that would be, the reason why that's true is because side angle side. So that's how I can make triangles congruent. The converse is also true. If I drop a if I have two isosceles, well, I have two side lengths of the triangle congruent. I could say that the base angles are congruent by the isosceles triangle theorem. I can drop a perpendicular there. And this would be a right angle, so I would end up with angle side. To show that other parts of the triangles were congruent. Angle bisector theorem. I bisect the angle here. The side length is the same, so I get angle side here to show that triangles are congruent. If I have the right angle here, if I cut that in half, then I don't have, remember we can't have angle side, but I do have a right angle, and so I do have a leg and a hypotenuse, so I can use hypotenuse leg to show that those are congruent. Okay. So, determine whether A must be a bisector of this. The answer is no, because 8 and 9 are not the same value. So no, A is not equidistant from sides A to T and A to R. Okay. Or equidistant from the angle so it doesn't split it in half. Okay. If I look at example 2, so these two angles are congruent. So because these two angles are congruent, then it does bisect it's an angle bisector of the larger angle measurement. So yes, the markings show XA is the bisector of angle TXR. Okay, so now I gotta write some proofs. Yay, proofs. We're almost done. Like, we're so close to being done with proofs. We're close. Okay. So statements, reasons. Okay. AM is congruent to BM. I guess we should probably, we should have done the bisector first. So let's go back. I should have written that PM is a bisector AB, and that's given. And then I can say that AM is congruent to BM. Nope. Definition of bisector. And then 3 would be PM is perpendicular to AB, and that is given. And then 4 angle PMA is congruent to angle PMB, and that's going to be hold on, I messed up. I pre-perpendicular first. Let's go back. I don't want to do that next. Because I want to show that these are right angles first. So angle PMA and angle PMB are right angles. And that is a definition of right angles. I was getting ahead of myself here when I write my proof. Okay, so now I can say that those are congruent because all it's late. All right angles are congruent. Okay, and then 6, we can say the PM is congruent to itself, and that's reflexive. And then 7, we can say triangle PMA is congruent to triangle PMB, and that would be side angle side. And then 8, AP is congruent to BP because of CPCTC. And then 9, the angle measurements, the segments are equal because definition of congruence. Okay. And then example 4 here. Let's go statements. Reasons. Another proof. Okay. So let's write our givens. So QS bisects. I don't know if you can hear my stomach growling. It's weird. It's because I stayed up too late. Angle PQR. And then SP is perpendicular to QP, and then SR is perpendicular to QR, and all of this is given. Okay, so then triangle SPQ and triangle SRQ are right triangles. And that is definition of right triangles. Okay, and then 3 is angle QPS is congruent to angle QRS, and all right angles are congruent. And then 4, QS is congruent to itself, and that is reflexive. And then 5, triangle SPQ is congruent to triangle SRQ, and that is angle side. And then 6, SP is congruent to SR, and that'll be CPCTC. And then 7, SP is equal to SR, and that is definition of congruence. All right, and that is it for this lesson.